Welcome to the deep dive. Today we're tackling cortisol. Everyone calls it the stress hormone and it gets a really bad rap.
It really does. People tend to fear it, but honestly, cortisol is absolutely essential for life. We wouldn't survive without it.
Exactly. So today we're going to dive deep into what cortisol actually does, beyond just stress. We'll look at how stress affects it, and importantly, what we can actually do to keep things balanced.
Right. We're drawing insights mainly from a detailed presentation transcript, looking at the vital functions, the whole stress response system, and crucially, some practical steps.
Our mission then is to unpack all this information about cortisol's impact
Yeah.
on our health and well-being and hopefully give you some really actionable knowledge.
Let's get into it. Cortisol does so much more than just react to you being chased by a lion, so to speak.
Okay, so what are some of these essential roles?
Well, first off, it increases glucose availability, gets sugar into your bloodstream quickly so your muscles and brain have energy. It actually inhibits insulin to help make that happen.
Right. Energy mobilization. Makes sense.
And it's a powerful anti-inflammatory. It suppresses inflammation, which is crucial short term. It also helps regulate how we use proteins, carbohydrates, and fats.
Supports cardiovascular health, too, I read. And blood pressure.
Absolutely. Maintaining blood pressure is a key function, and it enables gluconeogenesis, that's creating glucose from things like protein and lipids. Cortisol drives about 80% of that process.
Wow, 80%. So it's critical for energy even when we're not eating carbs.
Precisely. Plus, it plays roles in memory formation and modulating the immune response. So you see, it's not inherently bad at all. It's incredibly useful for survival.
Okay, so how is it actually produced? What's the typical pathway?
It starts in the brain. The hypothalamus releases a hormone called CRH, corticotropin-releasing hormone.
CRH, right?
That CRH travels just a tiny distance to the pituitary gland and tells it to release ACTH, adrenocorticotropic hormone.
ACTH.
You got it.
And that goes to...
ACTH travels through the bloodstream down to the adrenal glands, which sit on top of your kidneys. It prompts the adrenals to release adrenaline first, for that immediate rush, followed very quickly by cortisol.
That's the classic fight or flight response, isn't it?
Yeah.
Like if you're suddenly in danger or, competing in sports.
Exactly. You need that rapid energy and focus. But there's also a control mechanism, a negative feedback loop.
How does that work? To stop it just going crazy?
Once cortisol and adrenaline are circulating, they send signals back up to the pituitary and the hypothalamus, basically saying, okay, we've got enough. You can stop sending the signals now.
So it's a self-regulating system normally.
Under normal circumstances, yes. That loop keeps cortisol levels in check.
Now, the transcript talked about something called the General Adaptation Syndrome, or GAS, developed way back in the 1930s.
Yes, Hans Sully's work. GAS describes how the body responds to stress in 3 stages, and cortisol is central to this. The first is the alarm stage.
That's the initial reaction, fight or flight.
Exactly. The body recognizes a stressor, the HPA axis fires up, adrenaline and cortisol are released. This is actually what happens when you exercise, like running or lifting weights. It's a short-term stress that stimulates adaptation.
Okay, and the next stage, adaptation or resistance.
Right. If the stressor continues, the body tries to adapt. It keeps cortisol and other hormones elevated to try and maintain equilibrium, to resist the stress. This is how training makes you stronger. Your body adapts to the stress of lifting weights.
Public speaking used to be my absolute worst nightmare. I remember one time volunteering for a speech at work, and I just froze, completely blanked. It was awful.
Oh, wow. Yeah, that intense stress, that feeling, and the hormones kicking in. That's a perfect example of the alarm stage in action.
Totally. But I didn't give up. I kept forcing myself, even though I was terrified inside. And slowly, it got a tiny bit easier each time. The nerves were still there, cortisol probably spiking like mad, but somehow I adapted. Built up some resistance, I guess.
That's a fantastic real-world example of the adaptation phase. Your body, your mind, learn to cope with that specific stressor, public speaking, over time. You built resilience.
But what happens if the stress just doesn't let up? If it keeps coming day after day? That leads to the third stage, doesn't it? Exhaustion.
Yes, exactly. If stressors persist for too long without adequate recovery, the body's resources, its ability to adapt, just get depleted. This is where that negative feedback loop we talked about, the control system, can start to get damaged.
Okay, so the brakes start to fail.
Yeah.
Essentially. What does that mean for cortisol levels?
Well, when that negative feedback is damaged, it can paradoxically flip into positive feedback. Instead of cortisol signaling to stop production, the damaged system might keep signaling for more, causing cortisol to just keep spiking or stay chronically high.
And that's when we really start seeing all those negative health effects we typically associate with stress.
Precisely. Chronically elevated cortisol can really wreak havoc. It disrupts your circadian rhythm, so your sleep-wake cycle gets completely messed up.
Right. Trouble falling asleep, waking up in the night.
And it can lead to muscle breakdown because cortisol is catabolic while also promoting weight gain, especially that stubborn fat around the middle.
It seems contradictory, breaking down muscle but gaining fat.
It is, but it's about shifting resources. It also impacts skin health, think acne, poor healing, partly because cortisol influences sebum production. It's linked to digestive issues like IBS, and it can significantly decrease libido.
It really is a domino effect, isn't it? And I read it weakens the immune system, too. Makes you more prone to getting sick.
Definitely. It suppresses immune function long term. And crucially, we see strong links to increased risk of depression and anxiety. The mind-body connection is incredibly clear here.
And in really severe, prolonged cases.
It can even lead to actual pituitary damage. The constant signaling can eventually harm the gland itself.
Now, here's something that sounded a bit weird in the transcript. It said that being high for too long can actually lead to low cortisol eventually. How does that work?
It does sound counterintuitive, but think of it like the adrenal glands getting burned out. After being overstimulated for so long, they can eventually struggle to produce enough cortisol. This is sometimes referred to as adrenal fatigue or HPA axis dysfunction.
And that's bad, too.
Oh, yes. Having low cortisol can be just as problematic, if not more so in some ways. It can cause fatigue, low blood sugar, dizziness. And it can be particularly tough for people on very low-carb diets, like strict carnivore, because they rely heavily on cortisol for that gluconeogenesis process we mentioned to make glucose. Without enough cortisol, their energy production can really suffer.
Wow. Okay, so pituitary damage.
Yeah.
You mentioned that. It sounds like the pituitary gland is a really central player in this whole hormonal symphony.
It absolutely is. Often called the master gland for a reason. It's tiny, sits at the base of the brain, but it regulates a huge range of vital hormones, including the ACTH that controls cortisol. It's the critical link between the hypothalamus and the adrenal glands in that HPA axis.
And it has two main parts, right? Anterior and posterior.
Correct. The anterior pituitary, or adenohypophysis, and the posterior pituitary, the neurohypophysis. They have different origins and functions, releasing distinct sets of hormones.
Okay, let's break down the anterior pituitary first. What hormones does it manage? Sounds like a lot.
It does handle several key ones. There's human growth hormone, HGH, which is vital for, well, growth bone production, muscle development, organ health.
Then there's prolactin. Mainly for milk production.
Primarily, yes. It also releases luteinizing hormone, LH, and follicle-stimulating hormone, FSH. These are crucial for the gonads, ovaries, and testes controlling estrogen, progesterone, and testosterone production.
And ACTH, of course, which we've discussed, the one that tells the adrenals to make cortisol.
Exactly. And finally, there's thyroid-stimulating hormone, TSH, which, as the name suggests, signals the thyroid gland to produce its hormones, which regulate metabolism.
Okay, that's a busy lobe. What about the posterior pituitary? What does it release?
The posterior pituitary releases two main hormones that are actually made in the hypothalamus and stored here. One is vasopressin, also known as antidiuretic hormone, or ADH. It's key for regulating blood pressure and water balance.
And the other is oxytocin, the love hormone.
That's the one. Involved in bonding, but also crucial physical roles like milk letdown during breastfeeding and uterine contractions during childbirth.
So if the pituitary gets damaged from chronic stress or other causes, the ripple effects could be massive, affecting growth, fertility, metabolism, stress response, fluid balance, pretty much everything.
Precisely. Pituitary dysfunction can throw all of these systems out of balance. It could lead to things like dyslipidemia, unhealthy cholesterol levels, and that cortisol dysregulation we've been focusing on. It really underscores why protecting that HPA axis health is so fundamental.
It's just incredible how interconnected it all is. And it seems this elevated cortisol doesn't just stop at hormones, it starts messing with our neurotransmitters too.
Yes, this is a really fascinating and critical link. What the research shows is that stress via chronically elevated cortisol can actually decrease the levels of key neurotransmitters like dopamine and serotonin.
Dopamine and serotonin, those are the big ones, right? The feel-good chemicals, the ones involved in pleasure, motivation, mood. we're sort of hardwired to seek those feelings out.
We absolutely are. They're essential for our sense of well-being. And if our body isn't producing enough naturally, perhaps because cortisol levels are chronically high, we often find ourselves driven almost subconsciously to seek out artificial boosts.
And that's where things like sugar often come into the picture, isn't it?
Yeah.
It's such an easy, quick way to get a temporary hit.
It's a classic example. The sugar dopamine cycle. When you eat sugar, it triggers a release of dopamine through the brain's reward pathway, the mesolimbic pathway. It feels good, provides temporary pleasure, much like addictive drugs do.
But the problem is it's not a sustainable solution, and it comes with a big downside.
Exactly right. That initial surge of dopamine leads the brain to downregulate its dopamine receptors, basically. It becomes less sensitive. So after the sugar high wears off, dopamine levels can crash, often dipping below your baseline level. This leaves you feeling flat, maybe irritable, and craving more sugar to get that feeling back.
So it becomes this vicious cycle. You need more and more sugar just to get less and less of an effect, just to feel normal maybe.
Precisely. And it gets even more insidious. High sugar intake actually seems to blunt the activity of the prefrontal cortex.
The thinking part of the brain, the part that makes rational decisions.
That's the one. So when you're in that cycle, your ability to make sensible choices, to exert willpower, is impaired. That might explain those late-night binges on junk food you know you shouldn't be eating. Your rational brain is kind of offline.
Okay, that makes a scary amount of sense.
And cortisol's negative impact also extends to the hippocampus. This brain area is vital for forming new memories, for spatial navigation, and even for neurogenesis, creating new brain cells. Chronic stress and high cortisol damage the hippocampus, and guess what? Sugar does too. It's a double whammy, contributing to that cycle of poor choices, brain fog, and forgetfulness.
The source material also brought up grains, pointing out they break down into sugar. And it mentioned concerns about glyphosate contamination.
Yes, grains, like all carbohydrates, ultimately break down into glucose, impacting blood sugar and potentially feeding that reward cycle. The concern around glyphosate, a widely used herbicide, stems from various studies and its classification, for instance, under California's Prop 65, relating to potential cancer risk.
But there was another mechanism mentioned, too, about how glyphosate might interfere with neurotransmitter production itself.
That's a really interesting point. Glyphosate has been shown to block something called the shikimate pathway. This pathway is essential in plants and microbes for producing aromatic amino acids, specifically tryptophan, tyrosine, and phenylalanine.
And those amino acids are the building blocks for.
For many of our key neurotransmitters, tryptophan is the precursor for serotonin and tyrosine for dopamine. And a huge amount of this neurotransmitter synthesis, maybe up to 95%, actually happens in our gut, involving our gut microbes, which do use the shikimate pathway. So the concern is that glyphosate exposure could disrupt our gut microbiome's ability to produce these essential precursors.
Wow. So glyphosate could potentially limit the raw materials needed to make serotonin and dopamine.
That's the hypothesis, yes. And it doesn't stop there. Making neurotransmitters also requires various cofactors, vitamins and minerals like zinc, iron, magnesium, B3, B6, B9, B12.
And the source mentioned that things often found with grains, like in nuts and seeds too, can actually block the absorption of those minerals.
Correct. Compounds like lectins and phytic acid, which are naturally present in grains, legumes, nuts, and seeds, can bind to minerals like zinc, iron, and magnesium in the gut, preventing their absorption. They're often called anti-nutrients for this reason.
So let me see if I've got this right. High cortisol reduces dopamine and serotonin. We crave them, maybe turn to sugar or grains. Sugar gives a temporary hit but damages receptors and the decision-making brain. Grains also turn to sugar and might bring glyphosate, which hinders precursor production, and anti-nutrients that block the cofactors needed.
You've got it. It paints a picture of a really vicious cycle where the attempt to feel better through quick fixes actually undermines the body's fundamental ability to produce those feel-good chemicals naturally, especially when compounded by the effects of chronic stress and high cortisol.
And it's crucial to remember, as the source pointed out, that neurotransmitters aren't just about mood, are they? Their role is much broader.
Absolutely critical point. We talk a lot about dopamine and serotonin for mood, but neurotransmitters are fundamental messengers involved in regulating pretty much everything. Your heartbeat, your blood pressure, breathing, digestion, the healing process, sleep cycles, even the regulation of other hormones. They are systemically vital.
And processed foods often have more than just sugar working against us, right? other addictive components.
That's true. Things like certain types of vegetable oils, emulsifiers, and artificial flavorings used in ultra-processed foods can also interact with brain chemistry and gut health in ways that drive further consumption and cravings.
Okay, so this whole messy cycle, the high cortisol, the sugar cravings, the neurotransmitter disruption, how does insulin resistance fit into this picture?
It's tightly interwoven. That chronic exposure to high cortisol and high glucose levels from diet can lead directly to insulin resistance, where the body cells become less responsive to insulin's signal to take up glucose.
And this insulin resistance then has its own knock-on effects on hormones and neurotransmitters.
It does indeed. One significant pathway affected is the kynurenine pathway. This is how the body metabolizes tryptophan, that serotonin precursor. Under conditions of inflammation and insulin resistance, tryptophan metabolism gets shunted away from producing serotonin and melatonin, the sleep hormone derived from serotonin.
So less happy hormone, less sleep hormone. Where does the tryptophan go instead?
It gets diverted down a path that leads to the production of compounds like kynurenine and quinolinic acid, and ultimately can increase levels of glutamate.
Glutamate, that's an excitatory neurotransmitter, isn't it? Whereas GABA is the main calming one, so this throws that balance off.
Exactly. You end up with potentially reduced serotonin and melatonin, contributing to low mood and poor sleep. Simultaneously, you can get increased glutamate, which is excitatory, and potentially downregulated GABA, the calming neurotransmitter. This imbalance can lead towards a state of glutamate excitotoxicity.
Cytotoxicity. That sounds pretty bad. What are the potential consequences there?
It's implicated in a range of serious neurological issues. It can potentially contribute to neuronal damage seen in conditions like ALS, MS, Parkinson's. It's also linked to things like hypoglycemia, seizures, actual DNA damage, and perhaps, ironically, it can worsen depression and anxiety, which of course can then fuel more cravings for sugar or other quick fixes, perpetuating the entire cycle. It also blocks NAD production, which we should touch on.
It really does paint a grim picture for mental health if this cycle gets entrenched.
The cumulative mental health toll can be immense. We're talking about persistent sadness, apathy, losing interest in things you used to enjoy, significant changes in appetite or weight, constant fatigue, difficulty concentrating, feelings of worthlessness or guilt, physical restlessness or slowness, and in the most severe cases, even thoughts of death or suicide.
It's really sobering. And I have to say, personally, having gone through a period I now strongly suspect involves significant HPA axis damage, I was in a very, very dark place. It felt overwhelming and physical as much as mental. It's not just in your head.
Thank you for sharing that. It really powerfully illustrates how deeply these physiological imbalances, the hormones, the neurotransmitters, the inflammation impact our core mental and emotional state. It's profoundly real.
You mentioned NAD being blocked. The transcript touched on NAD as well. What is it, and why is it important in this context?
NAD, or nicotinamide adenine dinucleotide, is a really fundamental molecule. It's a coenzyme, meaning it helps enzymes do their jobs, and it's involved in hundreds of metabolic processes, particularly redox reactions, which are key for generating cellular energy. Think of it as absolutely essential for the power plants within your cells.
So crucial for energy. What else?
It's also vital for processes like DNA repair and chromatin remodeling, basically maintaining the health and integrity of our genetic material and controlling which genes get turned on or off.
And if NAD levels are low, that impacts DNA repair and maybe aging.
Yes, low NAD levels are linked to impaired DNA repair, which can accelerate aging and increase susceptibility to age-related diseases. And circling back to our main topic, chronically elevated cortisol has been shown to negatively impact NAD production and increase its consumption. So stress literally depletes this vital molecule needed for energy and repair.
Okay, so given how central cortisol is and how easily it can become dysregulated with modern life, understanding your own levels seems like a really important step. What are the ways to actually test cortisol?
Good question. There are several methods, each giving slightly different information. A standard blood test is common. It measures cortisol at one specific moment in time.
That useful?
It can be, but its limitation is that cortisol naturally fluctuates hugely throughout the day. It has a diurnal rhythm. A single blood draw, often done in the morning, doesn't capture that pattern. It's like taking one photo of a busy intersection and trying to understand the whole day's traffic flow.
Right. What about hair tests? I've heard of those.
Hair cortisol testing can give you a longer-term picture, reflecting average cortisol exposure over the past few months as the hair grew. It can be quite good for identifying chronically elevated cortisol.
But maybe not for low cortisol.
Generally, it's less sensitive for detecting low cortisol or the daily fluctuations.
Hmm.
Think of it like tree rings showing past seasons, but not today's weather.
Okay. And urine tests.
A 24-hour urine collection measures the total amount of cortisol metabolites excreted over a full day. This gives a better overall picture of total production than a single blood test, and again, it's often better at catching high cortisol states than low ones or rhythm issues.
Is there a test that doctors use specifically to check the HPA axis response?
Yes, there's the ACTH stimulation test. A doctor administers synthetic ACTH and then measures the adrenal gland's cortisol response over time. It directly assesses how well the pituitary adrenal connection is working, but it's a more involved clinical procedure.
So for someone wanting a practical, informative overview of their daily pattern, what did the source recommend?
The recommendation, and what's often considered the gold standard for assessing the diurnal rhythm, is the saliva test, usually done over 4 points in a day.
Saliva. How does that work?
It's super easy and non-invasive. You typically get a kit with small collection tubes and maybe cotton swabs or sponges. You collect saliva samples at specific times, usually upon waking, around midday, late afternoon, maybe 4 p.m., and then before bed.
And this shows the ups and downs through the day.
Exactly. It maps out your personal cortisol curve, showing if you get that healthy morning peak, the cortisol awakening response, if it drops appropriately during the day, and if it's nice and low at bedtime for sleep. It's excellent for spotting dysregulation in that natural rhythm.
The transcript mentioned a company, Medix, costing around $89. Are there others? Can your doctor do this?
Medix is one lab, yes, and there are several others offering direct-to-consumer saliva cortisol testing. Doctors can order these tests, sometimes through blood or saliva, but often the direct saliva kits are quicker and more convenient for getting that multi-point daily profile yourself.
Okay, so you do the test, you get the results. Maybe your cortisol is consistently high, or maybe it's flatlined low, or the rhythm is just totally off. What are the approaches to actually addressing these imbalances?
Right, the what next? Well, medication is certainly an option in specific diagnosed conditions. For instance, hydrocortisone replacement for Addison's disease, very low cortisol, or medications to lower cortisol in Cushing's disease, very high cortisol. These are serious medical treatments for specific diagnoses.
But for more general imbalances, maybe stress-induced.
For more functional imbalances, yes, medication might sometimes be used off-label, but most conventional treatments focus elsewhere. It's important to remember nearly all medications have potential side effects, and long-term use needs careful management.
What about natural remedies? Things like adaptogenic herbs are really popular, ashwagandha, rhodiola.
They are very popular, and many people find them helpful. Adaptogens are thought to help the body adapt to stress. However, it's crucial to approach them with awareness, too. As the transcript noted, even natural remedies can have side effects. Ashwagandha, for example, has been linked to liver issues in some rare cases with prolonged high doses. Other herbs might affect blood pressure or interact with medications.
Interestingly, the presenter in the source material actually had a somewhat surprising take, suggesting that maybe, in some short-term situations, a targeted medication might even be preferable to a complex herb.
Yes, the reasoning presented was that while a herb might seem natural, it contains hundreds, maybe thousands of different plant compounds, many with unknown effects or interactions in the body. A specific medication, despite potential side effects, targets a known pathway. It's a nuanced point, but the overarching message, regardless of using meds or herbs or neither, was the absolute necessity of addressing the root causes, the stressors, the diet, the lifestyle factors driving the imbalance in the first place. Symptom management alone isn't enough.
Right. Fix the source of the problem.
Yeah.
Now, something highlighted as potentially very beneficial, especially in the context of those negative effects of high cortisol, was ketones. How do they fit in?
This was a key point. Ketones, which your body produces when you follow a ketogenic diet, or which you can get from supplements like MCT oil or exogenous ketones, seem to have several beneficial effects that can counteract cortisol's downsides. A big one is that they increase NAD levels.
NAD again. That molecule for energy and DNA repair that cortisol depletes.
Exactly. By boosting NAD, ketones can support cellular energy production, enhance DNA repair mechanisms, promote the activity of sirtuins, longevity-related proteins, and aid chromatin remodeling, basically helping your cells stay healthy and resilient even under stress.
Okay, boosting NAD is huge.
Yeah.
Was there another mechanism mentioned? Something about adenosine?
Yes, this is really interesting. Ketones appear to increase the sensitivity of adenosine receptors in the brain. Adenosine is a neurotransmitter that promotes calmness and sleepiness. It builds up during the day.
So ketones make you more receptive to your body's own calming signals.
That seems to be the case. When these receptors are more sensitive, adenosine's effect is amplified. And a key effect of adenosine binding is driving down levels of glutamate, that excitatory neurotransmitter we talked about earlier. So this helps counteract glutamate excitotoxicity and shifts the balance back towards GABA, promoting a calmer state.
That makes sense. And it immediately makes me think about coffee. Caffeine blocks adenosine receptors.
Right.
Precisely.
And that's why the transcript cautioned about coffee consumption, especially for those with known HPA axis issues or high anxiety. While caffeine provides a temporary energy boost by blocking adenosine, overdoing it, especially when your system is already stressed, could potentially worsen glutamate excitotoxicity, anxiety, and sleep problems by constantly interfering with that natural calming pathway. Reducing or eliminating coffee might be something to consider in those cases.
Okay, that connection between ketones and chromatin remodeling.
Yeah.
That sounds important, but a bit technical. Can you break that down simply? How does DNA get repaired?
Sure. Think of your DNA like a huge library of incredibly long threads. To fit inside a tiny cell nucleus, these threads, DNA, are wrapped around protein spools called histones. This whole DNA histone package is called chromatin. Sticking out from the histones are little tails, and chemical tags can be attached to these tails.
Tags that control things.
Exactly. Some enzymes, called histone acetyltransferases or HATs, add acetyl tags. This tends to loosen the chromatin structure, like unspooling the thread, making the DNA accessible so its instructions can be read for making proteins needed for everything, including repair and healing.
Okay, so HATs open things up. What closes them?
Other enzymes called histone deacetylases, or HDACs, remove those acetyl tags. This generally causes the chromatin to fold up more tightly, making the DNA less accessible. Both opening HATs and closing HDACs are normal and necessary processes, but the balance matters.
And diet can affect this balance. The transcript mentioned grains and seed oils.
Yes. The suggestion was that diets high in certain components, like processed grains and seed oils, might promote excessive HDAC activity, potentially keeping DNA overly condensed and harder to access for repair. It even mentioned, quite surprisingly, that compounds in some vegetables have shown potential for clastogenesis, actual DNA strand breaks in certain lab settings, though context is key there.
But ketones do the opposite. They help keep things open.
That's the key takeaway. Ketone bodies, specifically beta-hydroxybutyrate, BHB, act as natural inhibitors of HDAC enzymes. By inhibiting HDACs, ketones help keep the chromatin in a more open, accessible state.
Allowing the repair instructions to be read.
Precisely. This allows for the transcription of necessary genes. Messenger RNA, mRNA, acts like a photocopy of a specific DNA instruction. This mRNA photocopy travels out to the ribosomes, the cell's protein-building factories. Ribosomes read the mRNA code 3 letters at a time, codons, and each codon attracts a specific amino acid. These amino acids are linked together into chains called peptides, which then fold up into functional proteins that the cell uses to repair damage, build structures, and carry out all its functions. Ketones essentially help ensure the repair crews can access the blueprints when needed.
That's a powerful mechanism. Okay, let's pivot to the really practical stuff. The source laid out a kind of cheat sheet with 4 main areas for managing cortisol. Let's start with diet.
Right. The dietary focus was strongly on a ketogenic approach, whether that's standard keto, low carb with veggies, or even a carnivore style, primarily to generate those beneficial ketones for the NAD and adenosine effects.
And a big emphasis on animal protein. Why specifically animal sources?
Yes, getting plenty of high-quality, highly bioavailable animal protein was stressed. The presenter noted an observation from their experience that purely plant-based diets often seem to correlate with cortisol or HPA axis issues, perhaps due to long-term intake of plant defense compounds or nutrient gaps. Animal proteins provide all essential amino acids in readily usable forms for tissue repair and hormone synthesis, basically. Top-tier building materials.
What about fats? Which ones are good?
Natural, healthy fats are encouraged. Especially important are omega-3 fatty acids from sources that aren't easily oxidized. Think fatty fish like salmon, mackerel, sardines, rather than relying solely on fragile seed oils. Healthy fats are crucial for hormone production and cell membrane health. And, simple but vital, adequate hydration. Water is fundamental for pretty much every bodily process, including HPA axis function and repair.
Were there any specific supplements mentioned as potentially helpful in this dietary context?
A few were highlighted. C8-MCT oil or exogenous ketones can give a direct ketone boost. Vitamin B5, pantothenic acid, was mentioned as important for adrenal function, ideally from food sources like liver, red meat, egg yolks, salmon. High-dose B5 supplements can sometimes cause digestive upset, and it might be a nutrient to be mindful of on standard keto or carnivore if organ meats aren't included. Lastly, unrefined sea salt was recommended, particularly for low-carb eaters, to help maintain sodium levels and support aldosterone, which works alongside cortisol and fluid balance and stress response.
Okay, moving to the second section, exercise. How should we approach exercise if cortisol is a concern?
The advice was nuanced. Timing might matter. Morning exercise could align better with natural cortisol rhythms, using that peak for energy. Crucially, recognizing exercise is a stressor is key.
So if you're already stressed or overtrained,
If you suspect cortisol dysregulation or HPA axis damage, the recommendation was actually to take a break from intense training for a few weeks. Focus instead on restorative practices like gentle walking, meditation, and grounding to allow the nervous system to calm down and recover.
and for people new to exercise or getting back into it,
Start slow and gentle. Low-intensity activities like yoga, stretching, or easy walking are great initially. They help upregulate beneficial pathways without massively stressing the system. Then gradually increase intensity and duration over weeks and months.
any guidelines on duration?
Yes, keeping workouts relatively short, maybe 60 minutes or less, was suggested. Newcomers might start with just 10-15 minutes. The big emphasis was on listening to your body and prioritizing rest and recovery. Overtraining is a major HPA axis disruptor, so avoiding that is paramount. More isn't always better.
Makes sense. The third section was other factors, and it included some really interesting lifestyle elements, starting with meditation. It sounded like this was huge for the presenter.
It really did. Meditation was presented as a powerful tool for calming the sympathetic nervous system. The presenters shared their personal routine, just 20 minutes daily using a simple gong timer app, 5 minutes focusing on gratitude, 5 minutes visualizing future goals and desired feelings, 5 minutes mindfulness, body scan, breath, and 5 minutes letting the mind wander freely.
And they mentioned specific results from visualization.
Yes, quite striking anecdotes about visualizing specific business outcomes or overcoming the fear of public speaking, which then seemed to manifest in reality. It really highlighted the potential power of focused intention and the mind-body connection in reducing stress and shaping outcomes.
Then there was grounding or earthing.
Yeah.
Literally touching the earth. Seems so basic.
It does, but the potential benefits for reducing inflammation and normalizing cortisol were emphasized, even just spending a few minutes with bare feet on grass, soil, or sand. For those who can't easily do that, grounding mats or sheets that connect to the earth via the grounding port of an outlet were mentioned as an alternative.
Natural light exposure was another one. We hear so much about avoiding sun. What's the angle here?
The focus was on getting natural light, especially early morning and late afternoon evening light when the sun is lower in the sky. This helps anchor your circadian rhythm. The specific advice was to actually take sunglasses off for maybe 5-10 minutes during these times,
Why no sunglasses?
to allow beneficial wavelength, like UVA, to reach the eyes and skin. This can stimulate things like melanocyte-stimulating hormone, MSH, and cholecystokinin, CCK, which are involved in hormone regulation, satiety signaling, and potentially reducing cravings. It's about smart, moderate exposure, not baking in midday sun.
And of course, quality sleep. Hugely important for cortisol. Any specific tips mentioned?
Yes, building on the meditation theme, doing that gratitude and visualization routine before bed was suggested to help induce sleepiness. Using high-frequency meditation music from YouTube, phone placed away from the bed, was another tip. A big one was avoiding looking at phone or tablet screens if you wake up during the night, as the blue light can disrupt melatonin and make it harder to fall back asleep.
Any other sleep hacks?
The presenter shared some personal ones. Getting up for a small protein-fat snack, like beef, egg, cheese, if genuine hunger wakes you, rather than lying there stressed. And finding specific sounds helpful, surprisingly. Using violent thunderstorm sounds on YouTube worked well for both them and their daughter. It's about finding what creates a calm, dark, and conducive sleep environment for you.
Okay, the final section of the cheat sheet was about something really crucial in our modern world. Actively removing modern stresses.
This is a big one. recognizing that our bodies evolved to handle acute, short-term stressors, like that lion chase. But modern life bombards us with chronic, low-grade, or psychological stressors that our systems aren't really designed for.
Like what kind of everyday things?
Oh, the list is long. Jarring alarm clocks, rushing to get ready, stressful commutes and traffic, constant email notifications, demanding bosses, financial worries, even just the 24/7 news cycle. It all adds up and keeps the HPA axis simmering.
So what can we actively do about it? We can't just quit our jobs or move off grid usually.
No, but we can mitigate. Simple things. Listen to calming meditation music or podcasts during your commute instead of stressful news. Try to consciously limit screen time, especially in the evening, or use blue blocking glasses if you have to be on screens.
And a really strong point was made about people.
Yes, the advice was quite blunt. Actively remove negative black hole people from your life where possible. People who consistently drain your energy or bring negativity. This can even include friends or family members if the relationship is truly toxic. Surround yourself instead with positive, energizing people. It's about managing the energy exchange.
Makes sense. What about our environment?
Creating a comfortable, calming home and workspace helps. Think natural light, opening windows for fresh air, decluttering. The presenter even shared a practical tip about using a chore app, Go Henry, to incentivize their daughter, reducing household friction and stress. It's about identifying your personal stressors and proactively finding ways to reduce or eliminate them.
Before we wrap up, we did have that listener question about using DHEA supplements specifically to manage elevated cortisol. What was the take on that?
Right, DHEA. It's another adrenal hormone, sometimes called an anti-cortisol hormone because it can have some balancing effects. So, theoretically, supplementing DHEA could potentially help offset high cortisol in some cases.
But there's a big but, isn't there?
Absolutely. The advice was crystal clear. You must test your DHEA levels first. DHEA is a powerful hormone, a precursor to testosterone and estrogen. Supplementing blindly if your levels are already adequate or high could cause significant hormonal imbalances and unwanted side effects like acne, hair loss, or mood changes. It's definitely not something to guess with. Test first, always.
Okay, that's a really important caution. So pulling all this together, the overarching message seems to be cortisol isn't the enemy, but our modern lifestyle can easily push it out of balance with wide-ranging negative consequences.
Precisely. Understanding its vital roles beyond just stress is the first step. Then recognizing how chronic stress, poor diet, lack of sleep, and other factors damage the regulatory systems is key. And finally, taking proactive steps using diet, exercise wisely, stress management techniques like meditation and grounding, optimizing sleep, and actively removing stressors. These things collectively support healthy cortisol levels and overall resilience.
And hearing the presenter's own story about recovering from what they believed was significant pituitary and HPA damage by applying these strategies, it really drives home that improvement is possible. It's not necessarily easy, but taking consistent action can make a real difference.
It really does. It highlights that these strategies, many of which seem quite simple on the surface, can have profound cumulative effects on our physiology and our mental well-being. And as the presenter noted, even the act of helping others, that positive energy exchange, can be incredibly energizing and healing itself.
So the key takeaway for everyone listening is that cortisol is vital, but its balance is delicate. Understanding how it works, how stress impacts it, and taking proactive lifestyle steps are crucial for managing it effectively.
Absolutely. Consider the testing options if you suspect an imbalance, and really look at implementing some of these practical strategies we've discussed to support your body's natural equilibrium.
And maybe a final thought to leave you with. Take a moment to consider which seemingly small, everyday habit or stressor in your life might be having a bigger impact on your cortisol and overall well-being than you realize. What's one small step you could take, starting today, to better understand or manage your body's response to stress?
That's a great question to ponder. Keep exploring, keep asking questions, and we'd love to hear about your own experiences as you navigate this complex but crucial aspect of health.